It's great to see you again, and I trust that you have a glass of sweet tea to enjoy as we settle in for another session of Back Porch Forestry. I'm Dr. David Merker, Extension Forester with the University of Tennessee. These back porch sessions are what I call 30-30s, roughly 30 slides in roughly 30 minutes. The intended audience is private forest landowners and foresters, but others might find this information interesting too. In a very general sense, I'm just covering the subject of trees and forests and forest management. At the end, you'll find a survey that I encourage you to participate in. So pull up your favorite seat, sip on that sweet tea, and let's enjoy together another session of Back Porch Forestry. I'm completing today a three-part series that studies the subject of elementary forest measurement. And so we're going to be building on what you've learned in the previous two sessions today. The subject is forest inventory today. And in general, we think of what is an inventory. Really, it's really just a detailed list of the goods that you might have or materials, maybe property. So it's an assessment of what you have. And some examples might be that we inventory our cupboards and our refrigerator before we go to the grocery store. Before we begin some type of construction project, we would inventory the nails and screws and lumber that we might have. And then each spring and fall, we inventory our closets for our clothing or drawers and so forth. Timber inventory is similar in that we are looking for a detailed list of the timber assets in our forest stands. We inventory to know what we have in our forest investment. The purpose of an inventory, really, timber inventories are conducted for a variety of reasons. We might inventory the timber to arrive at the value of the timber. That's probably the most common reason why we would inventory it. Perhaps we're selling our property or trying to buy property, and we need a forester to come out and inventory it for us. We sometimes inventory to establish a tax basis. That's very important once you purchase your property to know what you have so that when you sell your trees off, you can deplete your initial investment, and you need an inventory for that. We inventory for estate planning or maybe even for litigation at times. Forest management planning is also why we might inventory the timber. It helps us make decisions both current and future of what we're going to do with our land. And then finally, just to evaluate the damage, if there's been some damage to your stand, we want to evaluate the loss, perhaps from a tornado or fire or something like that. The procedure for timber inventory is fairly simple. We must first delineate the stands, and I'll share that with you in a moment. We then conduct the inventory, and then we must analyze the results. I'm not going to focus on number 3 today. We're going to be looking at number 1 and number 2. So let's begin with stand delineation. We delineate a forest into smaller, similar units, and these units are called stands. And we do this to try to minimize the variation in our plot samples. So if we're going to take plot samples, we want the stand to be as uniform as possible with regard to tree species. We don't want to mix our pine stands in with our hardwood stands, for instance. We delineate the stands in terms of the age of the stand and also the site quality. Upland versus bottomland, perhaps, is how we might delineate the stand. So let's do that. Here's an example of a property. This is Woody's property. And Woody has Turkey Creek that goes through the middle of the property. Up here is the old home site. Woody's old home site. I'm using the name Woody, by the way, because that's my grandpa name, Woody. And Woody retired a number of years ago, but before he did so, he established a pine plantation. What happened was the creek crossing blew out, and Woody got tired of trying to cross that with his tractor every year, and so he just planted this area back to pine. So it's 15 years old. The trees very soon will need their first thinning. Normally at about 17 to 18 years, we're going to thin those pine stands. So that's one stand. Up here is an area that Woody clear cut 35 years ago. He was preparing for retirement, wanted to build up his nest egg, and this stand was mature. It was ripe for picking, And so he clear cut it, and it's grown back to a beautiful young small saw log stand of oak and poplar and hickory, and maybe some cherry and beech are in there as well. And so that stand is ready for its first commercial thinning. Over here, right behind the house, is where Woody had his livestock, and this was heavily pastured, and there were some residual trees left out there when Woody stopped pasturing it. But underneath those residual trees developed a nice, beautiful young sapling stand of mixed hardwoods. And so we would call this a 2-age stand. And this stand, what it needs is for that overstory to be harvested off and to release this understory. And across the creek over here, this is the real stand that Woody's been protected through the years. This is where he's got some mature upland oak, and it's ready to be harvested. A great deal of value is tied up in this stand. So notice that we have 4 different unique stands, and we would not want to inventory all of these stands together. Rather, we would want to separate them out into unique stands. Why? In order to minimize that variation that I'm talking about, and that in turn will increase our accuracy. So we're now ready to conduct the inventory. A forester usually only measures a portion of the stand. And we ask, well, why would we want to do that? We need a sample. We just need a sample of the stand. And the reason is because in the interest of time and money, if there are 200 trees per acre on 40 acres, that means a forester would have to measure 8,000 trees to complete a 100% tally. Nobody has the time nor money for that. And so therefore, foresters attempt to obtain representative samples of the trees that are out there, the trees of interest. If all the trees on the 40 acres were identical, in other words, if we could clone the trees, then all we'd have to do is inventory one tree, get the diameter and height of it, and then expand that for the entire stand. But of course, we know that's not the case, that there are differences, excuse me, between the trees. And when there are only slight differences, then we don't have to take as many plots. So perhaps only one plot would be needed of sufficient size to encompass variation if there's only slight differences in the trees. But we must increase the number of sample plots as these differences between the trees also increase. So take a look at this stand. This is very typical upland hardwood. In this picture, I'm sure there's over a dozen different species out there. Each species is growing at a different rate, has a different market value. We have different diameters, different heights, different merchantable heights, a lot of understory trees out there. And so there's a lot of differences in this stand, so we need to increase the number of plots in order to get a representative sample. So an inventory then is going to begin with transect lines, and transect lines are simply these grid patterns that a stand is broken into. Typically, these transect lines are going to follow cardinal directions, north, south, east, west. Not always. Sometimes they'll follow property boundaries to make sure that the entire woods is canvassed properly. But these samples typically are put in on some type of a uniform sampling. So in other words, foresters might put their plots 4 chains apart. Now a chain is a measurement of 66 feet. And so we know our pace, and we know as we walk through the woods what a chain is. And typically when I have inventoried hardwood timber, I like this sample. This will give you about 1 plot per acre. And the plots would be about 264 feet apart. But notice there's a pattern to them, and it's not biased in any way. Here's how the samples would be laid out on an aerial photo. If we were to begin in the let's say upper right-hand corner of this, that would be a transect line. We drop down, put in another one, and so forth. But a point I want to make here is that you notice the topographic lines here, and this is telling me that right in here is a valley. And so where these topographic lines are real close together, that's indicating steep terrain. And so we don't want to bias our plots and just put them up here on the flat where it's easy to get around in the woods. We can't do that. And so where the plot stops, that's where the plot stops. And that's where we have to collect our data, whether or not it's on the side of a slope and it's real steep, down in a valley, or up on this flat somewhere. We want to lay out our samples in distinct transect lines. So again, a compass is used to establish these transect lines, making sure not to bias the lines by following topographic contours. Sample plots are taken along the transect lines, and a plot can either be a fixed radius plot or a variable radius plots. And I'll briefly explain both of these to you as we continue. Fixed radius and variable radius plots. We begin with fixed radius plots, and these are some common indices or common examples of fixed plot sizes. And so as we go across this, we see plot size, and in this case, it's a 1/100th of an acre plot. The radius of a 100th acre plot is 11.8 feet. And so if you were standing at plot center, you would then measure all the trees within an 11.8 foot radius all the way around you. Now, in a mature forest, this wouldn't be very practical because there's many plots that you would have where there would be no trees in it. And so a small plot size typically is used for something like seedlings. In other words, we might go out into a plantation after it's been planted a year or two later, and we want to assess the survival. So if we planted 435 trees per acre, if my radius is 11.8 feet, then I would expect to have, roughly 4 or 5 trees within this 1/100th acre plot. We see 1/10th acre plot. That's used when the stand develops. It's a little bit older, maybe for pulpwood. That would give you a 37-foot radius. And then a 1/5 acre plot could be used when you're dealing with larger diameter trees. That's a 52.7 foot radius. Here's an example of a fixed radius plot. It's a 1/10th acre, so it's a 37.3 foot radius. So that's you, or that's your forester standing in the middle of the plot. This represents that 37-foot radius like that. And so we're going to tally all the trees that are within the radius of this. In this case, you'll notice that we have 8 different trees, and that includes 4 pulpwood trees and 4 saw timber trees. And so if it's a 1/10th acre plot and we've tallied 8 trees, that means we would have on average, at least this plot would show us on average 80 trees per acre, 8 times 10. Now it's important to note that the center of the tree, in order to be included within the plot, the center of the tree at 4.5 feet must be within the boundary in order to be tallied. So this tree would be in, whereas this tree would be out, not included. This method of inventory is really pretty simple to explain. We've just done it in one slide, but it's difficult to implement. As you can imagine, if you're using a tape measure and you're trying to tape out 37 feet or larger if you're doing a 5th acre plot, and all the brush that might be in between that, it can be very challenging. So it's most practical, in my opinion, when you're dealing with 1/100th acre plots, small samples, for instance, if you're inventorying the success of your seedlings. Some typical data that might be collected on sample plots, we would collect the DBH, what's the diameter of the trees, what's the height, total height, if you're trying to estimate site index, or merchantable height, if you just want to know the value of the material that's out there. And then we might collect some data on quality or grade, so we can kind of help estimate the value of the stand. And basal area, which we've described in the previous sessions of back porch forestry, is something we can also collect, and that's very telling to us when we're collecting sample. Here's an example of measuring the diameter with a Biltmore stick or with a D-tape, a diameter tape. The diameter tape is going to be more accurate, but it's also more time consuming. So oftentimes foresters just use a Biltmore stick, or if they get good enough at it, they just kind of do an ocular estimate. We know what an 18-inch diameter tree is, and then periodically just kind of check ourselves to make sure that we're accurate. Now, tree height can also be measured using the merit hypsometer on the Biltmore stick. When we stand it upright, you can measure how many 16-foot logs are in the tree. And that can also be done with a clinometer, where you stand back a fixed distance from the tree and get the height that way. Of course, this can be done electronically too with handheld devices anymore and GPS units. All right, we're going to talk about the variable plot radius. I mentioned in one of the previous sessions that one of the most challenging things to teach is the concept of basal area. There's something that's even more difficult to teach, and that's variable plot radius. In my 3+ decades of working as a forester, I still have difficulty teaching what a variable plot radius is, but foresters have come up with this system because it's quicker. That's basically why we do it. It's quicker, and because it will, in the long run, it will tally more of the larger diameter trees, which oftentimes is what you're after, because that's where the value is. So you'll notice with this example that there is no fixed radius out it. The circle is gone, and we're measuring trees. You're still standing at plot center, but using a prism will encourage us to pick up smaller trees if they're close, but larger trees that are farther away. So we still may tally 8 trees as we did with the fixed radius plot, but they will be 8 different trees. A prism is used to help us determine which tree is in and which tree is out. And so going back to your high school physical science, you might remember the concept of light refraction. A prism is a small wedge. It's a piece of glass that's shaped like a wedge, angled on one side. And you remember light refraction, that's the bending of the light as it goes through a different medium. So if you put a straw down in a glass of water, your Sprite at the restaurant, you'll notice sometimes how the straw juts out to the side. That's because of light refraction. Well, light will refract through our prism too. And here's an example of a tree that would be in. So this item right here is the prism. When it's held up and light refracts through it, you'll see that the tree overlaps right there. There's an overlapping in the prism. That tree is tallied in. We come down to this end though, this tree would be out because there's light. There's a gap between the two, the prism and the tree itself. And then this would be a borderline tree, which are trees that could be either in or out. There's an equation that can help you determine that. But typically what foresters do is they'll tally one in and the next one they'll kick out. So if you want to see a prism actually in action, here's a prism that's used to determine whether a tree is in and should be tallied or not. So I've outlined the prism itself for you in this red just so that you can kind of see. That's the outline. That's a piece of glass prism that's being held here. And as the light refracts through it, you'll see that there's an overlapping there. Here's the edge of the tree that's been jutted out to the side, but there's overlapping there. So this tree would be in. But what about this tree? As this tree shows you, there's a slight gap there in the refraction, and that tree would be considered out. Important that you understand this is that this prism is looking at trees close and far away, but all the trees are viewed at 4.5 feet above the ground. That's that diameter breast height, or DBH, that we oftentimes refer to, DBH. Well, this is going to be a mouthful here, and I'm going to spend a little time on it here, but this prism we're using is called a 10-factor prism. There are 20-factor prism. I think there's even a 5-factor prism, but in our region, we use the 10-factor prism. And that means that each tree that's tallied as in represents 10 square feet of basal area per acre. So you can go back to a couple sessions. We talked about basal area recently and what that means, but it's the cross-sectional area of a tree at 4.5 feet above the ground. What would that area represent in square feet? And so each tree that we tally with the 10-factor prism represents 10 square foot of basal area. So if we put in 10 plots and we have a total of 140 in trees that we've counted in those 10 plots, that means that we have an average of 14 trees per plot. What does that mean? Well, if we take the 14 trees per plot average and we multiply it by this 10-factor prism, that gives us 140 square foot of basal area per acre. Remember, we talked about this not long ago. 140 square foot of basal area is pretty high. If your benchmark to thin is 120 square feet, then it's time to thin. So as a refresher, here's that table that I'm referring to, the Gingrich chart. And our basal area in this particular example, we said, wow, it's running 140 square foot of basal area. When you project that over, that's well into the overstock range, and it's past time to thin. We'd like to say when we start approaching 120 square feet, somewhere in that, maybe 110, that's when you better have a forester out to your property and consider thinning and bring that stand back down to this fully stocked range so that it will continue growing and remain healthy. Our goal with timber inventory, is it accuracy or is it precision? I was asked this question a number of years ago, what's the difference between accuracy and precision? And precision means that we get the same results when repeated over and over again. That doesn't necessarily mean it's accurate. So if you're sighting your gun in for the first time and you fire 5 shots and they all hit up here, we have attained precision. That's pretty good, but we have not attained accuracy. And so you're going to dial your sight down to make sure that we get accuracy. Accuracy hits the bullseye every time. And so with accuracy, that's what we're looking for. Really, we've attained both precision and accuracy, and we want both. And you're wondering, what does this have to do with timber inventory? Well, it has a lot to do with it, because we obtain in timber inventories both accuracy and precision by doing a number of things and by doing it right. We first delineate our stand. So we've gone through that. We want to have uniform stands. Then we conduct the inventory, but important to this is that we conduct the inventory carefully, not rapidly and carelessly. And so we take measurements accurately, both at diameter, breast height, both the log height. Of course, we want to know the species and grade and so forth. And then we also achieve both accuracy and precision by increasing the number of sample plots. I'm going to start drawing this to a close, but there's always seems to be one slide that I really focus on, and I'm about to show you that, and I want to address the subject of growth, forest growth. Growth can be expressed numerically, so we can measure the forest and then numerically put that growth in a form that you can understand. So it can be expressed for a single tree. Growth can be expressed for a single tree. We can say this tree is growing at this rate, or collectively for the entire stand, and that helps us make decisions, forest management decisions. So growth is also called increment, and remember that as we go through that increment. Forest growth is expressed oftentimes as annual increment. So that's the growth for a specific year. How much did the tree grow, or did the stand grow this year? Periodic annual increment then is the growth for a specified period of years. So maybe over a 10-year period or 5-year, whatever you wish to assess. That's the periodic annual increment. And then the final example here is the mean annual increment. And what I mean by that is what's the average growth over the entire lifespan of the tree or of the stand. Annual increment, periodic annual increment, and mean annual increment. And here's the picture that I want to spend some time on. You can accomplish forest education so much easier when you've got a tree cookie to look at, because it really tells the story for us if we examine it closely. I've got 2 arrows here, and so I'll just ask you the question. Remember, we first came up with the annual increment. Well, looking at those 2 arrows, you can easily tell which year the tree and perhaps the forest was growing better. That's pretty easy to see. The annual increment is very tiny here, and it's approaching a 1/4 inch, probably about maybe a 1/5 of an inch right here. So it's easy to see that the annual increment is greater here than there. But what about the periodic annual increment? Which 10-year period would have a higher periodic annual increment? Well, visually, I think you can see that too, but let's put some numbers to this. If you think about it, during this period right here, I've estimated this to be 1.5 inches total, 1.5 inches total. Now remember, A tree doesn't just grow on one side, it grows on both sides. So really, that tree hasn't grown 1.5 inches over this 10-year period. It's grown 3 inches. 1.5 inches twice is 3 inches. Now, when we divide that 3 inches by 10 years, that gives us a periodic annual increment of 1/3 of an inch per year. So we've averaged 1/3 of an inch, some years a little bit farther better, some years a little bit worse, but we've averaged 1/3 of an inch over the 10-year period. That's good. That's acceptable. That's tolerable. I can live with that on a typical upland site. But what about this other example down below, the periodic annual increment here? Of course, we're looking at roughly a 1/2 inch growth. Again, we're going to double that. So that means over 10 years, we've only grown 1 inch in 10 years, which gives us 1/10 of an inch per year for our periodic annual increment. That's nothing less than hideous. That's horrible. That's something we should be ashamed of. And that's certainly not going to help us achieve our financial goals very quickly for growing trees at that rate. This, by the way, is a white oak tree. Let's continue on with this then and look at the mean annual increment. Remember, the mean annual increment is over the lifespan of the tree, how we average. So what we're looking at here is a tree that's 63 years old, and it's 9 inches in diameter. Wow. 63 years old and only, I should say, 9 inches in diameter. That's 0.15 inch per year would be our mean annual increment, which means that we're only growing about overall an average of 1.5 inches in diameter in 10 years. Surely we can do better than that, and we should do better than that. And why didn't we do better than that here? Well, the annual growth rings, which I call the annual interest rate, tells us the story. If we look at this tree early on, and I think this actually was probably a tree that had been suppressed. So it got started in the forest. It wasn't growing well, and you can tell that by how close the growth rings are together. But right here, bam, something happened. You can see an increase in growth rings, and most likely this stand was harvested. I suppose a tree could have fallen next to it and provided growing space, but the tree took a jump at that point. It grew fairly well for a number of years. I can't get my cursor to work very good, but you see it began to slow down right about in this period, and then it really shut down right in here. And that's when the forest was harvested again. And of course, that gave us a great jump, a period of rapid growth. The trees were pushing their way into the new growing space, and then it shut down again, and then it was thinned again. And so the point I want to make is we want to try to eliminate periods like that and periods like this where the growth rate is really paltry. And so we need to be entering our forest stands sooner, quicker, to avoid these downturns and increase the growing rate. And so that's done through the process of thinning and professional help with a forester to know that proper timing, when to pull the trigger. Well, I'm ready to conclude this. Maybe you need another fill up your glass of sweet tea too, so let's do that. This series, this 3-part series, hopefully has been a practical introduction aimed at the subject of forest measurement. And it's targeted largely to the novice. Foresters understand this information already, but it provides an understanding of forest measurement which will aid you in communicating with others and also help you with financial planning. So I hope that you'll join us in the future for additional sessions. Here is a survey that I encourage you to fill out. You can pause this at any time, write down that URL. It's also available back on YouTube in the subject line. And then I encourage you for those that want to take this to a higher level, I wrote a publication a number of years ago with another faculty member titled Conducting a Simple Timber Inventory. And so this will expand upon what we've studied today. You can simply Google that title and my name and find it, or the URL will be on the subject line on YouTube as well. So that concludes our session. Thank you. I look forward to seeing you in the woods again sometime soon.